Okay, so we're going to be looking at this problem-solving question with differential equations, and there is some really tricky stuff in here. A kite is rising at a rate which is proportional to its height. That's important at any time. That is, the rate of change of height with respect to time is equal to kh. K is really a stand-in for that word proportional. So the change in height with respect to time is equal to something times the height. Between 0 and 300, where h is in meters and t is in minutes. Obviously, k is a constant. It's our constant of proportionality. If the initial height is 2 meters and the height is 20 meters after 1 minute, find the height at any time and the height to the nearest meter after 3 minutes. So really, we're just solving dh dt for h, first of all, to find the height at any time. So I'm going to cheat a little bit here. I'm going to try some different movie magic. So first of all, dh dt, and we've got h as our, it's in terms of h. Now obviously that's not going to work because usually it would be in terms of t, so we're inverting stuff again. So it's going to look something like this. dh dt equals kh, and then we invert it and we get dt dh equals 1 on kh. So from here we start solving for t, and then once we've got it solved for t, we'll be able to rearrange it. So t equals the integral of 1 on kh. We're going to get a log here of 1 on k log base eh plus c. And then this bit will really sort of blow your mind. I'll just talk about the rationale here. 1 on k log base eh plus c. And then the suggestion is that you can put the c in terms of log base e, and not just terms of log base eh, but also with a 1 on k in it. All right, check this out. So we've taken c and turned it into 1 on k log base e a. Again, where a is like an arbitrary number, and the k is the same k that's here. But it doesn't really matter because we know that we can have some value for a that will generate an arbitrary constant. Now the reason they've done this is so that you can factorize and bring 1 on k outside, and then simplify log base eh and log base ea using your log laws, and you'll get something like t equals 1 on k log base e ah. So now we've got this thing in terms of t, but you sort of need to know what the a is, because the a is the stand-in for our c, if you like. If we know what our a is, then we've got this solved, and we can do that by subbing in our initial condition, which they told us here. Initial height is 2 meters and the height is 20 meters after 1 minute. So initial height is 2 meters. That's the initial condition here. We'll use that other bit in a little bit. All right, so subbing it in when t equals 2, 0 equals this, solving it for a. You'll just have to rearrange that a little bit, but a equals 1/2. Since log base e1 equals 0, you may not remember that log law, but log base e, or log base anything, 1 is always equal to 0. And then we can substitute a back into our equation. And this is our equation for time. Time equals 1 on k log base e h. So that's given us our a value, but it hasn't really given us a k value yet. So given that we've already used one condition, our initial height is 2 meters, if we sub in the other one, we should be able to find out a k value. T equals 1, h equals 20, and we can solve it to be k is approximately 2.303 or log base e 10. Okay, and this is our rule for t now. T is equal to log base e h onto 2.303, but obviously you want to rearrange that to make it the subject, because we want to solve our differential equation, but we want to make h the subject. So rearranging. So now we have h equals 2e to the 2.303t. That's the height at any time t. And then finally the question was, what is the height to the nearest meter after 3 minutes to the nearest meter? Okay, so substituting 3 in there should be really easy. 2002, so it's 2 times e to the power of 6.909 is approximately 2002. I think that's it. Okay, so it's all pretty okay stuff. The only bits that you really need to watch out for are this word proportional, in which case it's going to be integral equal kh, and then you can work from there. They did something really fancy here with log base EH, but all they want to do is be able to get A in next to that H, and to do that you need 2 logs. And then putting in boundary conditions to first find the A, and then putting in another condition to find the K, and then from there it's basically solving equations. There you go.